Good morning, Algebra 2. This is APEX, Semester 2, Chapter 3 notes. We're going to start with arithmetic sequences. So arithmetic sequences are essentially lines. So it's the difference between consecutive terms are the same. In other words, it has a slope. Okay? And the slope in this case is called the common difference, or D. Okay? But it's really, once again, just the equation of a line. So what happens is, in an arithmetic sequence, I go from 1 to 3, so I added 2, so I would add 2 again, add 2 again. Okay, so it's a pattern. It's an addition subtraction pattern. Okay, so this is addition or subtraction. Okay. So the differences between the consecutive terms are the same. We call these terms A1, A2, A3, all the way up to A sub n. So here this is A1, A2, A3, A4. So essentially that's my number of my term, okay, or we could do this as an x value, okay, so my first term would be 1, 1, so this would be my a sub 1, okay, and my value I get is 1. My a sub 2 would be 3, or would be, sorry, my a sub 2 would be 2, okay, because it's my second term, and my value would be 3, okay. So these are my outputs, this is my input, okay? So let's take a look at what the equation of an arithmetic sequence. So to find the nth term, so if I wanted to know, what the 100th term is, I could do that because I have an equation. A equals A1 plus n minus 1 times the quantity D. And usually it'll be written like this so that you can remember to distribute that D when you're finding that formula. But let's take a look at, notice here I say point slope form, let's take a look at what point slope form is. So it's y minus y1 equals m times x minus x1. And if I were to add y1 to both sides, I would get y equals y1 plus m times x minus x1. Well, that's the same exact thing. The only difference is this is called A1 instead of Y1. Okay, so it's our first output. Okay, and our X1 value is 1. Because in most arithmetic sequences, you're going to start with that first value. Okay, so let's go on ahead and let's find a couple of formulas. So it says find the formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. So D, or my slope, is going to be 3, and my first term, a sub 1, is going to be 2. So if you can't remember this formula, you can use point slope form. Okay? So here, this point, it would be my first point, and I would get 2 for that first point. Okay? So now I have a slope and I have a point, and I can plug it into point slope. Okay? Or you can use the a sub n formula. Okay? So a, or a sub n, equals my A1 value, which is 2, plus I'm adding 3 each time, times n minus 1. Now we're going to go on ahead and distribute, okay? And I get 2 plus 3n minus 3, so I get 3n minus 1. And so if I wanted to find my 12th term, okay, or what my 12th value would be, I could plug a 12 in here. So 3 times 12 would be 36 minus 1 would be 35. So my point there would be 1235. Okay? So these are giving you coordinates. Okay? They're giving you values, output values. Okay, so this next one, this is why it's really good to know that this is point slope form. So this one says, well, the fourth term is 20. So we're going to have a point here for 20. Okay? And then the 13th term is 65, so that's going to be 65. Now I need to go on ahead and find my slope or my difference. Okay, so this is point slope form here. So we need an m, which is our slope. So that's rise over run, so y2 minus y1 over x2 minus x1 equals 65 minus 20 over 13 minus 4. Gives us 45 over 9, which is just 5. So my slope is 5. Okay, and I can use either one of these points. I'm going to use the point 4 and 20. Okay? So I'm going to say y minus y1 equals slope times that was my m, times x minus 4. Okay? And now I can go ahead and add 20 to both sides, okay, but make sure that you distribute. Okay? So you might want to do this in 2 steps, so we'll just do it in 2 steps. Y minus 20 equals 5x minus 20. Add 20 to both sides, so we're putting it in slope-intercept form, okay, which is what our final is. So we get y equals 5x. Okay. So an arithmetic sequence is a line. Do not forget that. Okay, an arithmetic sequence is a line. Okay. But we also have geometric sequences. Geometric sequences are connected by a common number as well, but they're linked by multiplication or division. The common ratio is the value each term is multiplied or divided by to find the next. So our common ratio is what we're multiplied or divided by, and we're going to call that value r. Okay. So it says find the next term here. So in order to get from 1 to 3, well, I could add 2 or I could multiply by 3. Okay, so if I was looking at this and didn't know it was a geometric sequence. To get from 3 to 9, well, I couldn't add 2, so I know it's not that one. So I could multiply by 3. Okay? So now I'm starting to see my pattern here. So if I continue multiplying times 3, I would get, what would I get? 81 times 3, which is 243. My common ratio is r, and that equals 3. That's the number I was multiplying by. So a geometric sequence, just like our arithmetic sequence, has a formula. There's our formula. A sub n equals a, and that's really a1, times r to the n minus 1 power. Now, this is really the same thing as this, which you guys have seen in the past. It's an exponential growth or decay function, which is actually where we're going next with this. Okay, so you guys have seen this before. So it says write an explicit formula. Okay, so we just call it an explicit formula because we want to know, based off of our first term, what is it? What's our value? Okay, so write an explicit formula for each example. So the first thing we need to do is we need to find what we're multiplying by. We never find what we're dividing by. We always find what we're multiplying by. Okay, so our r is always a multiplication. So here we're multiplying times 2 each time. So our a sub n then is going to be our first term times our ratio to the n minus 1 power. And it's just that ratio to the n minus 1 power, not the whole thing. So let's take a look at the next one. So to get from here to here, I'm dividing by 5. So anytime I'm getting a smaller value, what I'm going to do is I'm going to go backwards. Okay? So here, I'm going to take 10 and divide it by 50, which gives me 1 over 5. So I'm dividing by 5, but it's the same thing as multiplying by 1 over 5. Okay, so same thing. If I take 2 divided by 10, okay, work backwards, 1/5. Okay, so that will help you if it's decreasing. So if it's going down, decreasing, okay, do the next term by the first one, because that will give you the multiplication. We want multiplication, not division. Okay, so now I can write my formula. So now my formula is 50 times 1/5 to the n minus 1 power. And I can find any term I want that way. Okay, so let's go ahead and take a look at these. So this one says find a1, r, a to the 5th, and a to the 6th. And yes, I know a to the 5th is here already. Okay, but I just am doing that so that you guys can make sure that you have the correct values. Okay, or the correct formula. So a sub 1 is 8. R, well, it's going down, so I'm going to do 4 divided by 8, which is 1/2. Okay, so my R is 1/2. Just remember, if it's going down, work backwards. Okay? All right, so now I'm going to have 8 times 1/2 to the n minus 1 power. So a to the 5th then is going to be 8 times 1/2 times n minus 1, which would make that 4. So 1/2 to the 4th power times 8 is going to equal 1/2. Okay, which it should. Okay, a to the 6th, same thing, a times 1/2, 6 minus 1, and you're going to get 1/4. And we're just plugging that into our calculators. Just remember that when you plug it into your calculator, so like for a to the 5th, I'm going to do 0.5 to the 4th power first, and then do my multiplication. Okay, so it's always just the ratio that's raised to an exponent, not the whole thing. Okay, so go ahead and take a look at the next one and see if you can figure out its formula. I will continue in a minute. Pause it, whatever. Okay, so our a sub 1 is 18, and we're getting smaller again, so we're going to work backwards. So 6 over 18 is 1 out of 3. Okay, so our ratio is 1/3. That's what we're multiplying by. So it's going to be 18, so a sub n equals 18 times 1/3 to the n minus 1 power. So with that, we can find our a sub 5 and our a sub 6. Okay, so we're going to plug 5 in for n, and then we're going to plug 6 in for n. And you should get 0.222, which is 2 divided by 9, or 2/9. And then you should get 0.074 continuing. So if the common ratio is greater than 1, then it shows exponential growth. In other words, your graph is going up. If the common ratio is less than 1, then it's going to show exponential decay. So your graph is going to go down. So it'll be going down really fast. And we're going to get a lot into exponential growth and decay because we're going to be dealing with a lot of exponential functions. Okay, but the last part of this section is a sum of a finite set of terms in a series, which is called a partial sum. So if I have some series like this one, and I wanted to find the sum of these terms, okay, then I could find each of them and add them together, but sometimes that gets to be a lot of work, like if you're trying to find the number of seats in an auditorium or something like that. Then you would have to do a lot of addition, a lot of counting, and then you'd have to add all these up and hope that you added them all up correctly. So instead, there's a formula. So sum of some number of terms, okay, so n is going to be how many terms we're looking at, equals a sub 1 times 1 minus r to the n power. So do the r to the n power first, not with that minus sign, all by itself, and then subtract it from 1. Okay, divided by 1 minus r. So let's go ahead and work this problem here. So let's go ahead and find the 6th partial sum. So what I'm going to do is I'm going to find my 6th partial sum. So I'm going to write my formula in here. So it's 2 times 1 minus, well, we have to figure out what's happening. So to get from 2 to 6, I can add 4 or multiplying by 3. So that's going to be 3 to the 6th power all over 1 minus 3. Okay. So remember, I said do this without the negative sign. So I'm going to do 3 to the 6th power. Okay, that's 729. So now I'm going to have 2 times 1 minus 729 all over negative 2. This just happens to be a 2 and a 2. It doesn't always work out that way, as you'll see next. Okay, so now we're going to do 2 times negative 728, and we're going to divide that by negative 2, and we get 242. And if we add these ones up, well, this is 8 plus 18 plus 54 plus 162. Well, we know it's got to be, because of this 162 and this 54, it's got to be at least 200 and something. Okay, so we know that we're going in the right direction there. Okay, so let's take a look at this next one. I realized on this one that I forgot a 10 here. So it should be 40 plus 20 plus 10 plus 5 over 2. Okay. So I forgot to put that 10 in there. All right, so let's go on ahead and find our partial sum. So S sub n, okay, or in this case we're going to find 6, equals 2 times 1 minus. All right, so to get from here to here, okay, I'm going to do 20 over 40, which is going to give me 1/2. It's getting smaller, so that's why I went backwards. Okay, and that's going to be 1/2 to the 6th power. Okay, and then the parentheses. Okay, so we don't want that whole thing raised. And then 1 minus 1/2. Okay, so now we're going to get 2 times 1 minus, let's see, 0.5 to the 6th power is 0.015625. All over 1 minus 1/2 is 1/2. So now we're going to go on ahead and plug that in, and we get 77.5. So I'm just going to plug it in to be sure that my answer was right. Times 2 divided by 0.5 equals, what did I do here? Oh, I did this before. I started out with 2. That should be a 40. And that's got to be our first term. I did that when I was working it earlier too, and I was like, what in the world is going on? So yeah, so that's times 40. Okay, so 0.984375 is what I get when I do 1 minus that number, times 40, and then divided by 0.5. And you should get 78.75. Okay. So double check and make sure that that's what you got. It's a lot easier than adding these all up and counting them. And let's make sure that this is in the ballpark at least. So 40 plus 20 is 60, plus 10 is 30, 70, plus 5 is 75. Okay, so we're right there in the ballpark. Okay, so you want to double check and make sure that it's a reasonable value. All right, well, you guys have a good day, and I will see you next time.